Welcome to day 24 of calculus. Today we are going to continue our analysis of functions using the first and second derivatives. In this question, it gives us a function f of x, and it asks us to find all maximums and minimums and points of inflection. So we're going to be using the first and second derivatives to find those things. So first, let's find the derivative. The derivative we can find using the shortcut because this is a polynomial, so it's going to be 3x squared minus 6x minus 9. And now our goal is to find out where the derivative is equal to 0, because that's where a max or a min could occur. So we set the derivative equal to 0, and then we start factoring. We can pull out a 3 and get x squared minus 2x minus 3. And then we can factor quite nicely into x minus 3 times x plus 1 equals 0. So that means x is going to be 3 or negative 1. So those are the x values that make the derivative 0. And we're trying to find points. So for maximums and minimums, by default, find points. So let's just find those now, meaning what is f of 3? And what is f of negative 1 to get the y values for each case? If you plug in 3 into this equation, you end up with negative 19. And if you plug in negative 1 into the original function equation, you end up with 13. So we have 2 points here. We have 3 comma negative 19, and we have negative 1 comma 13. And we know that at each point, at each of these 2 points, the derivative is 0. So they could be where a max or a min occurs. What we need to know is, are they maxes or mins, or neither? Actually, it is possible for them to be neither. And we're going to find out if they're maxes or mins by looking at concavity. Remember, if it's concave down and the derivative is 0, then it's a max. So that's concave down. And if it's concave up and the derivative is 0, so concave up, then it's going to be a min. So we need to know what is the concavity at each of these points. To study concavity, we need the second derivative. So if this is our first derivative right here, our second derivative, it's still a polynomial. We can use the shortcut as going to be 6x minus 6. So now we want to know what is the concavity at each of these points. So we need to plug in the x values into the second derivative. So it's going to be f double prime at 3 is going to be 18 minus 6 is 12, and that's greater than 0. So that means concave up. So that tells us that this, which one was it? Concave up. So this is going to be a minimum because the derivative is 0 and it's concave up there. And then we do f double prime at negative 1. And then we end up with 6 times negative 1 minus 6 is negative 12, which is less than 0. So that means it's going to be concave down. So in the first case, it was concave up, which meant it was going to be a minimum. It's concave down, which means that this has to be a max. So there's a minimum point there and a maximum point there. Now we need to find points of inflection. A point of inflection is where concavity changes from positive to negative or negative to positive. So the way we figure out where that happens, if that happens, is looking at the second derivative, which is 6x minus 6, and setting that equal to 0. So that means that 6 times x minus 1 equals 0. So x equals 1 is the only solution. So we know that the second derivative, when x is 1, the second derivative is 0. We need to know what happens to the left of 0 and to the right of 0. Remember, you only need to test one value, to left and right of 1, excuse me. So a number to the left of 1 is 0. So let's plug in. So we have f double prime at 0. F double prime at 0 is going to be 6 times 0 minus 6, which is negative 6. So that means over here it's entirely going to be negative. As long as one value is negative, then all of the ones to the left are negative. And what's to the right? Well, let's plug in, how about, let's say 2, because that's to the right of 1 here. So f double prime of 2 is going to be 6 times 2 minus 6 is indeed 6. So it's going to be positive here. So what do we now know? We know that the concavity changes from concave down to concave up across the x equals 1 number. We want a point. So we know that there's going to be a point of inflection when x is 1, we need the y value. To get the y value, you need to plug into the original equation. So you plug 1 into the original equation. If you plug 1 into the original equation, you end up with -3. So our point of inflection is 1, -3. All of this comes together if you wanted to sketch it roughly to look something like this. The function will be concave down and then concave up. And there's a maximum right here at -113. There's a minimum right here at 3, -19. And then there's a point of inflection where the concavity changes right there at 1, -3. It means that you have concave down from here to here. So concave down, and then it changes to concave up right there. That's what we've figured out. So now we're going to use a sign diagram to sketch a graph with all of these properties. When you're sketching a graph given a bunch of properties, take the easy stuff and use that first. So this first one says the function when x is 1, y is -3. So let's plot that point. 1, -3 is right there. So we know that that point right there has to be on this. So we've used this. Nice. Let's use a few other things from f of x right here. It tells us that f of x is 0 at -5. So when x is -5, y is 0. This 0 tells us, oh, it's at -2, so that's going to be, we have another point which is going to be -2, 0, and then there's one more right here, so that correlates to 3, 0. So we have 3 times the function crosses the x-axis because this is the y values right there. Y is f of x. So we plot those 3 points. We have -5, 0 right there. We have -2, 0, and we have 3, 0. So plot the easiest stuff first. So we've done everything we can with the function itself. So now let's look at what's going on here. We know from the first derivative where it's positive, that means that the function is increasing where the derivative is positive. The derivative is positive in these cases, it is increasing. And then we also know right here that the function is decreasing. So this tells us the function is increasing from -infinity to, it looks like 3. And also right here from, it looks like 1 to infinity. You can kind of assume it's going to keep on going like that. So the function is increasing all the way to 3, and then it's going to be, so it's increasing there, and it's going to be decreasing where it's blue. So right here, that's from everywhere else, which is going to be from, that's -3 right there. -3 all the way to 1. So now we know where the function is increasing, and so we can put in some dotted lines here. We know, so it's not a very good dotted line, but I'm doing my best here. So there's x equals -3, and this right here is x is equal to 1. So we know from here to here, it's increasing, the function. From here to here, it's increasing, but from here to here, it is decreasing. So what does that mean if it's going from increasing to decreasing? If you go from increasing to decreasing, it means you have a max as it crosses there. And then if it goes from decreasing to increasing, we know there's a min right here. So there's going to be some sort of max and then min. So to be specific, we know that there's going to be a max right here at x equals -3, and right here there's going to be a minimum. So we can just kind of pick it. It doesn't tell us where it crosses, but we know it's going to be a max wherever it crosses here. So we know it's a max. And then there's going to be, oh, we know where it crosses here, a min right there. It has to cross right there. So now we can draw a little bit more because we know this is increasing. We know it's going to have to go like this. And then we also know it's increasing like this. We know those two things. And we know it's going to be decreasing this entire time like this. The last thing we need to make sure of is that the concavity matches what it should. So we know right here all the way to 0, so it's negative there, that means concave down because those are negative signs. And then it's going to be concave up where it's positive. So it should be concave down all the way to this value. This x value right there is -1. That's when x is -1. So all the way until x is -1, it's concave down. So we can draw another line here. We know that all the way until here, it's going to be concave down. And I didn't really do that. You see there's a problem right there in the middle. So what I'm going to do is I'm going to change this a little bit here. We know it's going to be concave down all the way until then. So it's concave down there. So it's going to be still concave down. So we want this to be concave down until it hits negative. You'll notice it's a little hard to keep it concave down there, but we can get it done. And maybe that's, remember we can change the height of this. Let's make it a little lower right here. Let's make it a little lower. So we have this, and then it's going to be concave down. So it's concave down from here to here. So it's concave down all the way to there. And then at where it hits -1 right there, it's going to change to concave up. It's going to change. You want to shape this a little bit. It's going to change to concave up. So that's not very curved. So I'm going to redraw it. It's one of the beauties of these surfaces. Let's make it concave down. Sorry, concave up. So now it changed to concave up right there. So all of that information is there. The one thing that can slide around is how high this is. That can slide around that max because it doesn't tell us where it has to be. So everything is as it should be. So we know it's increasing from here all the way to there, from here to there, and it's decreasing right in the middle, right to there, and then the concavity matches where it should. Do these piece by piece and start with the easy stuff. So let's take the easy on this. So the first part says f of 2 is -5. So that means we have the point 2, -5. So 2, -5 is right there. So let's then take all the stuff that the function has. So the function crosses at 0 right there. So that means you have the point x-intercept of 1, 0. And then this one looks like it's about right there. So maybe 4, 0. You can kind of, it's about 4. So these are x-intercepts. So we know they're at 1, 0 and 4, 0, like that. And you'll notice that I misread this. It's not 1, it's -1. So it should be over right there. So -1 and 4. So we have 3 points. That's helpful. So we've used everything from here and here. So now we know, now we look at the second derivative. It's negative, so it's falling, and then it's 0, and then it's falling again. That's interesting. So right here, something happens. The derivative is 0, but then it continues falling. So that means the function falls, gets to 0, and then it keeps on falling. So at that point right there, it's neither a min or a max. But right here, it then changes to increasing. So we know that the function is decreasing, -infinity all the way to, what's this x value? -3. And then the derivative is 0 at -3, but then it's also decreasing from, again, on the other side of -3 all the way to 2. And it's increasing after 2, so 2 to infinity. So if something is decreasing and then increasing, so it's decreasing, decreasing, and then increasing. If something is decreasing and increasing, this must be a minimum right here. It must be a minimum, so there is a minimum when x is equal to 2. Oh, we already have that there. So let's put this in like this. Use green again. So we know it's going to be a minimum right here. It's going to be a minimum right there. And then here, though, right here at x is equal to -1 right there, we know here it's not going to be not min or max because the function keeps on falling. It's going to be decreasing up until that point and then keep decreasing. So let's look at concavity now. Let's look at concavity. So what do we have here? We have positive and positive. So that means for the second derivative, it's going to be concave up and concave up. But in the middle here, it's going to be concave down. So where does it change? At these places right there. So that, you got to read this carefully, it goes down to here. So at -1, it changes concavity. So up until here, in here, it's going to be concave up. And then from -1, from here to here, -1, it looks like it's going from all the way to 0, all the way to, sorry, not 0, it's going to all the way from -3. I stopped that a little too soon there. This right here is -3. Excuse me, this 0 right here correlates to -3 right there. So that actually is, that not min or max is right here at -3. X equals -3. So then we know it is concave up all the way to x equals -3. It's concave up, so it's concave up all the way to -3. And then from -3 all the way to 0, because this right here, this 0 right there, that goes down to that 0. So it means that to the y-axis, it's going to be concave down right in here, concave down all the way to 0, excuse me, to 0, right to there. And then after 0, it's going to go back to being concave up, concave up. So what do we know? We know it's concave up and increasing here. So it's going to keep on going. It's going to cross there and keep on going up. And it's concave up all the way until it hits the x-axis. So it's going to be concave up like this. So this is concave up. That's a little bent the wrong direction, so I'll keep on bending it the right direction like this. So it's concave up like this. So that's where concave up. And then we know it changes to concave down, but it has to go through this point right there. So it changes to concave down, and then we know it's also decreasing all the way to the left of 2. So that means it's gonna be concave down, but it still is decreasing. So it's decreasing and kind of looking like this. So it's concave down to here, and there's going to be a point of inflection right about there, a point of inflection. It changes concavity. But now it's concave down, but it's still, now it changes here to concave up, but it's still decreasing. So it's going to be like this. So again, you have concave up right here, and you have concave up right there, and then here you have concave down. So then you check, is it increasing and decreasing in the right places? Well, the yellow is going to be where it's decreasing, which is right here. So it decreases. Is it decreasing? It is. And then the derivative as it hits -3 should be 0. It should be zeroing right there. So we could make that a little smoother there. And then does it still decrease? It does. It still decreases all the way to here. And then it starts to increase afterwards, right like this. So this function, again, it's going down. The derivative is 0. And then it goes down, changes concavity, and then comes back up. That's the general shape of what's going on. The only thing that you could smooth out a little bit here is that this curve right here, the derivative here should be 0. So it should be 0, and then you can make that a little bit more defined right there.